Fractions. The very sound of the word, well, it kind of freaks most of us out. So here, I'm going to take a stab at explaining the progression of fractions. And it begins in first grade. And it starts with a crazy word, partition. And I think that students should be able to use that word as well. So in first grade, students should be able to partition squares and rectangles into halves and quarters, which can also be represented or called fourths. The vocabulary development here is the biggest piece in first grade. So they could also say a quarter of, a fourth of, or a half of. In second grade, students build on their understanding of halves, quarters, and fourths, and they're introduced to the idea of thirds. Again, they should be using that term, thirds or a third of. When students leave second grade, a big piece of understanding they should leave with is though even though shapes can appear different, they actually can have the same size. So this brings us to third grade. It's a really big year for the development of fractions because here students are beginning to really truly develop that meaning of a fraction. And it's the first time that students see fractions written as a symbol. So even though we're talking about symbols, we really need to place our emphasis as teachers on the visual representation of fractions. So how can we do that? Well, one way we can do that is by creating a length model. Here you see that we've taken a strip of paper and folded it up into 4 parts. Another way, which isn't really explored in third grade, is the use of a set model. Here in this set model, you can see that 3/4 of the bears are green. And the last way that we can represent fractions is one that I think we're all pretty much familiar with, and that's the area model. Here, 3/4 of our square is yellow. As students are building this understanding, we need to make a connection back to their understanding of what they have with whole numbers. So just as whole numbers, take for example this number 4, is built from units of 1, fractions, in this case 3/4, is built from 3/1/4, a fourth plus a fourth plus a fourth. Big understanding here. Let's go back to that length model. Well, that length model is a really powerful tool because it helps build students' understanding, which can also be done through a number line. Here's another number line. What number is the question mark? Here, let me help. Wait a minute, that's greater than 1. Well, in third grade, students need to see that fractions can also represent numbers greater than 1. It's the sum of unit fractions. So we might want to get students to begin counting with fractions. 1/3, 2/3, 1, 4/3, 5/3, 2. Let's get our students counting by fractions. Counting circles are a great tool to get students understanding and seeing the sum of unit fractions and that repetition and the structure of numbers. So as students begin to learn dividing in parts of a whole and partitioning up shapes, they begin to explore this idea of equivalent fractions. So here we're going to take 4 lines and we're going to divide them up. We're going to partition them all into equal parts. And as we partition them all up into equal parts, we begin to see that, hey, some of these line up a little bit. Here students are beginning to explore the idea of equivalent fractions. So 1/2 is equal to 2/4, which is equal to 3/6, which is really the same as 4/8. The big piece here that students really need to see and we need to push and promote is that the size of the whole doesn't change, just the size of the parts do. But even though we're talking about fractions, students need to also understand that whole numbers can also be written as fractions. Take for example the number 1. Here's 3 ways that we can represent that number 1. As students begin to build that understanding and they continue to build their understanding, we compare fractions. Here, 1/4 is greater than a half. Now you might be thinking I'm crazy, but I'm not. See, 1/4 is, yep, 1/4 is greater than a half. It comes back to this understanding that students need to see that we have to be talking about the same size whole. So let's compare these 2 fractions, 3/4 and 5/4. Well, here we see that a quarter is a rhombus. So if we have 3 1/4, that's actually less than 5 1/4. And that's a common denominator strategy. Another way we can compare fractions is is if we have a common numerator. Here we have 1 as a common numerator. Yeah, common numerator. It doesn't quite sound right, but here students have this understanding and should be building this understanding of a common denominator and common numerator. Here students can see that 1/6 is actually a smaller piece than 1/3, and therefore it's less. So in 4th grade, we continue to build students' understanding of comparing fractions. They come to us with this understanding of common denominators, common numerators, and here's another strategy students can use to compare 7/8 and 11/12. Now, they're both missing one part from a whole, but students know because of their understanding of a unit fraction that an eighth is actually larger than a 12th, and therefore it's farther away, it's missing a greater piece of its whole. And the last strategy we can use to compare fractions is with a benchmark. Here we'll use a benchmark of a half. Well, we know that 4/8 is equal to a half, and half of 5 is 2.5. Yep, we're not using any butterflies here, and butterflies have no place with comparing fractions. So we have 4 strategies for comparing fractions, but let's go back and revisit that idea of building equivalence. Well, here we have a half, and if we take our half and we multiply it by 2, by dividing it, we can actually see that 2/4 is the same as a half. And if we repeat that procedure, we see that we have 4/8. Here, this area model helps students visually see equivalent fractions. Now, after students have explored with fractions lots of times, they begin to see this pattern in numbers. And I think it's our job as the teacher to kind of allow them to see this. So students begin to see that whatever we do to the numerator, we do to the denominator. But I think that it's important that kids come up with that understanding, not just us telling them. There's a whole bunch happening here in this crazy world of fractions. So hopefully we can all make sense of it, so we're not scared of them. Let's continue the conversation online. Take care.